Good morning. My name is Gianluca Roascio and I'm a second-year PhD student from Politecnico di Torino. Today, I'm going to present my research activities through this short video. Hope you enjoy! My thesis title is Vulnerability Tolerant Architectures. Right after my graduation, even before the PhD, I started passionating through the security of smart objects. Every aspect of our life is digitalized, and this is not only related to the fact that we use PC and smartphone to work and live every day. Our cars, our home objects, our watches, our buildings are nowadays smart and exchange a lot of information about ourselves. Advances in cryptography and network security put communication under a strong shield, but what about devices themselves? They are little electronic pieces exposed to the world, and then even physically accessible to any possible malicious actor. As the expert realized in the last years, if the hardware or the deepest control firmware of these devices is compromised, then all the protections applied at the upper layers might result as useless. My research is focused on the design techniques to make computing platforms resilient to binary attacks. Binary attacks are a very powerful exploit category which allows to literally sneak inside the application running on a target machine and to corrupt the machine code in order to force the victim to do whatever the attacker wants. Binary attacks exploit the fact that most of the embedded or IoT platforms run control code written in C or C++. These languages allow a very deep optimization of resources, but also allow to freely handle memory. This may result in bugs such as buffer overflow, in which it is possible to corrupt memory bytes which are adjacent to a portion reserved for a user input buffer. An attacker can directly inject code inside the memory, or even just corrupt the return address of a function to make the program jump to execute whatever it wants. The best way to counteract these intrusions is providing control flow integrity, which means that somewhere in hardware or software, there should be a verifier of the runtime control flow graph. The verifier is instructed in such a way that no branches are taken outside the ones originally intended by the programmer. I studied and experimented 3 different secure design approaches for embedded platforms. One is fully hardware-based protection. To test it, we implemented a custom version of the RISC-V architecture, and we inserted hardware modules able to block the attack without the program even knowing that. The second is hypervisor-based protection. Here we modified the BAO hypervisor in such a way to assign tasks with hard time requirement to one computing core, and tasks with soft time requirements to another core. And the control flow integrity checks are performed in a crossed way, with one core protecting the other and vice versa. Third, we studied a hybrid protection, specialized for mixed CPU FPGA architectures, in which the reconfigurable hardware portion validates the branches that are performed by the processor. As you can see, all of these 3 approaches allow a hardware platform to execute vulnerable code without being exposed to risk. This is exactly what design for security means, and creating architectures that are resilient to vulnerabilities. My research activities are not limited to design of secure computing architectures. In fact, I am part of the Turing node of the Cybersecurity National Laboratory, which is the funder of my doctorate, and with which we carry out important specialized consultancy and training activities for the main Italian public institutions, such as the Ministry of Defense, the Ministry of Justice, the Civil Protection Department, and the newly created National Cybersecurity Agency. Here in Turin, we have set up Paideusis, a cyber training camp for the education of students, new researchers, and IT security experts. Paideusis is a hybrid cyber range unique in Italy. It hosts realistic scenarios that include physically vulnerable hardware devices and reproduce related security problems to be addressed and solved. And this concludes my presentation. I thank you for the attention. I leave you my contacts in such a way that you can ask me some information about my activities and one of the Cybersecurity National Laboratory. Goodbye.